Okay, today we're going to look at what I think is quite a cool function. It's the natural log of x. Now I'm going to look at this one from the start a little bit differently, is that we're going to start off with a bit of a proof. So I'll show you what I do. Right, the natural log is log to base e of x, or ln of x. Right? And log to base e is the opposite of e to the power of. So, in other words, if we had e to the power of log x, that would equal x, or log of e to the x would be x. They undo each other, right? And we're going to use that identity to show what the differential of log of x is. So what I'm going to do is I'm going to use the chain rule. We're going to have f of x equals e to the log x. Right? Now, what we're going to do this, what we're going to do is we will then realize that we're going to have two functions. One is e to the u, and one of them is log x. So u equals log x, and the function of u equals e to the x. Right? So we differentiate the first one, the function of u. F dash of u is going to be e to the x. E to the u, sorry. It should be e to the u. Let's just get rid of that one. Back to the normal pen. E to the power of u. So the differential of it is e to the power of u. And f dash of x is going to be e to the power of log x times the differential of log x. Times u dash. Right. Now we know e to the power of x is going to e to the power of log x is going to be 1. Right? So this one here is also f of x equals x. And so when we differentiate it, we know that f dash of x will have to be 1. So simplifying this, we've got f dash of x is going to be x times u dash. That also has to equal 1 because it's the same thing as here. So what do we multiply? When we multiply x by something, we end up with 1. Well, the only thing that x must be, that u has to be there, or u dash has to be, is f dash of x equals x times 1 over x equals 1. So u dash equals 1 over x. Alright. Now u, remember, is e to the power of, is log x. Right? So u equals natural log of x, and u dash equals 1 over x. Alright, let's look at that a little more formally. What that means is that if we have a function f of x equals log x, the natural log of x, then f dash of x equals 1 over x. Right. And so we're going to put that together. We'll use the chain rule for any problems with this. So if we had g of x equals log of 3x minus 1, well, we first of all differentiate the outside, then the inside. So g dash of x is going to be 1 over 3x minus 1 times, and then we differentiate the inside. So we first of all do that bit, goes to there, and then this bit comes down here. And 3x minus 1 differentiate is going to be 3. So our final answer for g dash of x is going to be 3 over 3x minus 1. Another one, if we had y equals 4 log x minus x squared. Right, well, we do the chain rule first of all, or the product rule. The 4 is going to disappear, so that just is going to end up on the top. So we're going to end up with dy over dx equals 4 over x minus x squared. Then we differentiate what's inside it, times 1 minus 2x. So all together, we're going to get dy over dx equals 4, 1 minus 2x over x, 1 minus x. Right, and it's not going to get any simpler than that. So that's differentiating the natural log. Let's have a look at how that works when we have a look at some questions. Here we go. Question 1. Y equals log of 3x plus 2. 2. Y equals log of x plus 1 times x minus 3, and 3 function of x equals log x minus 2 plus x plus 3. Right, we'll see you in class.